Greetings everyone! I thought I'd make a quick video to review graphing exponential growth and decay models. This video can be used to help you study for your quiz or on any homework. I apologize that my voice sounds funny with this cold, but I wanted to make sure this video gets done so you can use it before our next quiz. Let's quickly review the basics of an exponential growth or decay function. Some of the values are the same as all of our other functions. For example, the value out front is your vertical stretch or compression. Remember, it can be positive or negative. The negative would flip the graph. Our subtract h is our horizontal shift. Remember the sign rule. If it says -5, that actually means we're going to add 5. And our plus k, that's our vertical shift, which means I'm going to add or subtract a value from my y column. What's different is going to be our b value. This b value can change. This is going to be called our factor. Remember that if the b value is greater than 1, that's my growth factor. If my b value is between 0 and 1, that's my decay factor. Notice there's no negatives because the negative is part of your a value. It's not part of your factor. Again, remember b will be different every time, which means you're going to have to create your own parent table each time. It's not like cube roots or square roots where you can just remember the table and reuse it. Because this is a new word, I wanted to go over this again. An asymptote's a line that the graph approaches more and more closely but never truly touches. So think of it like a wall. I can get really close to a wall, but I'm never actually in the wall or the wall. So I can only approach it as close as I possibly can. Your asymptotes in this lesson are always going to be horizontal. Because it's a horizontal line, it's always going to be written as y equals a number. And in this particular section, what's nice is the number is always going to be your vertical shift value. So if I have a function that's 2 to the x plus 5, my asymptote is going to be y equals 5. If I have a function that is 3 to the x minus 2, there's no vertical shift. So technically I could say I'm adding 0. So my asymptote would be y equals 0. Let's do two examples, one with a whole number factor and one with a fraction factor. So first of all, I have to create my table. Start with the same x values no matter what. Now if I want to create this table, I need to take my parent function, which is 3 to the x, just your base value. If I do 3 to the x value of -2, that negative would flip it. So now I have 1 over 3 squared, which becomes 1 over 9. If I have 3 to the -1, that would flip it. Now it's 1 over 3 to the first, which is 1/3. If I have 3 to the 0, anything to the 0 powers 1. This is always your point. You will always have 0, 1 on your parent table. 3 to the 1 is going to be 3. 3 squared is 9. Notice the pattern here. We times by 3, we times by 3, we times by 3. Okay, you should see that pattern in your parent table. Okay, so keep an eye out for that. Look for that. All right, so now we want to apply our transformations. So for our transformations, we use them the way we did every other function. We read the graph left to right. So first of all, I have a 2 out front. That is my vertical stretch. So it's going to apply to my y values, times 2, times 2, times 2. Next, I have a -2 for my horizontal shift, which means I'm going to add 2 to every x value. Then last, I have a vertical shift of +1, which means I'm going to add 1 to each of my y values. So let's create our new and final table. The left side should always be easier. So -2 plus 2, -1 plus 2, 0 plus 2, 1 plus 2, 2 plus 2. Nice, easy pattern, and you should always see that. On the right here, I have 1/9 times 2. If you need to do a little bit of work, then do that. 1/9 times 2, that would be 2 over 1. We multiply fractions straight across. Then I need to add 1. Plus 1 over 1. To add fractions, we do need a common denominator. So that's going to be 9 and 9, which gets me to 11/9. Now, I want your answers in fraction form. If you use a calculator to check your work or to find the value, that's fine. Just make sure you write it as a fraction. Mixed or improper doesn't matter to me. If I convert this to a mixed, I would have 1 over 2/9. Well, look at that. 1/9 doubled is 2/9. 2/9 plus 1 is 1 and 2/9. So sometimes the conceptual is actually easier than doing all the fraction work. Let's do conceptual math for the next fraction. 1/3 times 2, or 1/3 doubled, is 2/3. 2/3 plus 1 is 1 and 2/3. When we're adding 1, that's really easy. The rest should be really easy. 1 times 2, 2. 2 plus 1, 3. 3 times 2, 6. 6 plus 1, 7. 9 times 2, 18. 18 plus 1, 19. So again, you should only have to do work on 2 values. All right, let's graph this and make sure that it looks like what it should look like. Meaning, this is a growth problem, so it should increase rapidly. So at 0, I'm at 1 and 2/9, very, very small. At 1, I'm at 1 and 2/3, just a little bit higher. At 2, I'm at 3. At 3, I'm at 7. At 4, I'm at 19, which means I increase very rapidly. So from this point, I should shoot almost straight up. As I connect these, I notice that I'm hitting a line that I'm not going to cross. Remember that your vertical shift is your asymptote. Ooh, horrible spelling, sorry there. So that means the rest of my graph should hover along the 1 but not cross it. So I know that's kind of hard to do with some small graphs, but just make sure you do not cross 1 and make sure you have arrows on the ends. Let's answer some additional questions. Your parent function was our 3 to the x. That's what we started with. Your type, due to the fact that this is greater than 1, is growth. Your domain, you go forever left and you go forever right, which will be true for every growth and decay graph we have. Your range, how low, it goes to 1 and goes up till forever. Now here's something that's a little different. We don't actually touch or equal 1, so this is a parenthesis. So with growth and decay, all of your domain ranges should be parentheses. Let's take a look at one more. This time we have a fraction for our factor. So let's start with our table. Same 5 values. If I look, my parent function is just the b value to the x. That negative, that's out front. That's part of my stretch, compression, flip deal that I'm going to do later. I'm worried about my base under my exponent. So if I apply that 1/2 and I make it to the -2 power, that means I flip it because it's negative. So now it's 2 over 1 to the +2. I distribute that squared onto top and bottom, which gives me a 4 over a 1, which is just 4. All right, let's do it again. 1/2 to the -1. That means I flip my fraction to make my exponent positive. If I distribute 1, I end up with 2 over 1, 2. Anything to the 0 power is 1, that's your freebie. Anything to the first power is itself. And when I have 1/2 squared, I distribute that squared, so I get 1/4. Okay. Take a look for your pattern. Your pattern is half. So I should see there that I'm dividing by 2 or times by half. Divide by 2, divide by 2, divide by 2. Or do the reverse. Times by 2, times by 2, times by 2, times by 2. Look for that pattern, you guys. If you don't see that pattern, you know already that something's up with your work. Okay, now let's apply our shifts to our table. Let's start off. For this left, I have technically a -1 in there. So with that -1, I'm going to multiply every y value by -1. Next, I have a +1 for my horizontal shift, so I'm going to subtract 1 from every x value. And then I have a -2 for my vertical shift, so I'm going to subtract 2 from every y value. Okay, take care of the calculations here. Left side, do the left side first, it's always easier. -2 minus 1, -1 minus 1, 0 minus 1, 1 minus 1, 2 minus 1. Do the easy side first. Off to the right, I'm going to take care of the whole numbers first. 4 times -1, -4, -4 minus 2. 2 times -1, -2 minus 2. 1 times -1, -1 minus 2. 1/2 times -1. I'm going to do a little bit of work here. 1/2 times -1 is -1/2. If I'm going to subtract 2 over 1, I'm going to get a common denominator of 2. -1 minus 4 is -5. Carry your common denominator over. You could also think of it as a mixed fraction. If I have -1/2 and I subtract 2, I'm at -2.5. Think of the conceptual side of it. Let's do it again. If I have a 1/4 times -1, I've got -1/4. If I'm subtracting 2 over 1, common denominator of 4. -1 minus 8 is -9/4, which is the same as saying -2 1/4. So again, you should only have to do work on 2 of the points. The rest should come easy. If they don't, something's up. All right, let's take a look at graphing this. We know it should be decay because it's less than 1 for my base. So let's see what that looks like. -3, -6. 1, 2, 3, 4, 5, 6. -2, -4. -1, -3. 0, -2.5. 1, -2.25. I can see that I'm going to drastically drop down here, and I can see that my asymptote is at -2, so I should not touch -2. I should go along that -2. So as I continue my graph, go along that -2 value. Now wait a second. If I identify this information, I have my parent at 1/2 to the x, which implies it's decay. So why is this not going down? It's not going down in the sense of like this because of this negative out front. Look at the negative. So it's a decay function that's flipped. So think about this. It originally would have looked like this if it was decay, but we flipped it down because of that negative. Okay, so it still makes sense with the problem. My domain, forever left, forever right. My range goes from -infinity up to -2 parentheses. So watch those ranges when you have a negative out front. It flips it around. So those are the 2 types of examples that can help you review. If you're kind of a steps person, sort of walk through those steps. Step 1 is to create your parent table. You're not going to have them all memorized, so create that parent table. Remember, you should only have 2 points that require some work. The rest should be quick math. Okay, then we apply transformations. All the moves that we've always done to our tables. This is going to be the same as our square roots, cubed roots, quadratics, and many other functions we're going to explore. 3, make sure you graph it correctly. By correctly, I mean show the asymptote in the sense of go along the asymptote, make sure you have arrows on the ends, make sure it looks the way it should. In step 4, let's say identify key features. Right? What's its domain? What's its range? What's its parent? Is it growth or decay? All of those things. So feel free to rewrite those problems, see if you can rework them on your own. You need a way to study, this is your option. If you need more examples, let me know. I'm always willing to make more options for you. All right, have a good one, and we'll see you next time.